to do this contest, weekly contest 163, the first problem, which is an easy problem, it's problem 1216, shift 2D grid. And the problem says we get a 2D grid of size m by n and an integer k, and we need to shift the grid k times, right? And what does that mean? So a shift here, they mean by that is doing one of these operations, right? So if it's any column, then you need to move grid at, so basically doing these operations, the cell at position ij needs to move to cell to be at the position ij plus 1. So the previous value that was at ij, we need to move it to ij plus 1, and the previous value that was on any row last column needs to move to the next row first column, right? And then any the letter that was at the bottom right needs to move to the top left, which is this grid m-1, n-1 needs to move to grid 0, 0. So essentially that's what we'll be doing here. So you can see 1 moves to the next column, so 1. And then n-1, if we look at one of these, we'll look at 3 needs to move to the next row, position 0. So you could see 3 became here. And then you could see, for example, 5 became, 6 here became the first of the next row. So you get the idea. And you could see here 9 became on the top left. So this is essentially what the problem asks us, and the constraint is that we might have at most 15 rows and 15 columns, and the values are between minus 1000 and 1000, and k can go all the way up to 100. So you can see here we can do an open cubed algorithm, right? Because that would be 100 multiplied by 15 multiplied by 15. So it's still within the rounds of maybe 25,000 or something like that. So it's still reasonable. Yeah, so that's what, so that means that we can try to do a brute force solution here. And essentially the brute force solution would be just a direct application of the problem, right? So what do we need to do for that? So the first thing we need to realize is that let's just simulate it as the problem says, you know, not complicate things at all. So let's just take this and comment it here for ourselves, and just so that would be just comment it out here, and let's just apply it. Okay, so the first thing we need to do here is let's just define our rows and columns here, just the values. So rows would be the length of grid, and columns would be the length of grid position 0, right? And then we need to do k shift, the shift operation that is described here. We need to do it k times. So let's just do a for loop that does it k times. So I'm just going to simulate what the problem says, right? So this is range of k, and then we need to go through for every cell. We need to shift it, right? But to not have to deal with, because if we override in place, maybe something that we just moved needs to be moved somewhere first. So just to avoid all the headache of like maybe something that we moved right now should have been moved, like the order of moving things is not correct, maybe let's just avoid doing it in place and create a new array where we'll save the input, and then we'll put that in the original grid. And so first we'll just define a new grid with only 0 values. So that would be a range of columns, and then this is a range of rows. So like this, and then we'll go through every row and every column, so that we can go through every cell and shift it, right? So just go over every cell and shift. Right, and so that would be just saying, okay, let's go through every cell, just remember there is one constraint here, which is that the element at position I n minus 1, right? That one doesn't move to ij plus 1, right? That one moves to the first column of this, the row after that, right? Because even if we did like put columns here, the operation that we need to do is this one, which is that grid ij plus 1 is going, grid ij is moving to this cell, so that means this one is going to be on that cell, right? And so that means we can't put columns because then we would have columns plus 1, so we can't do it anyway. And plus also the problem says only for that cell we should move it instead to grid I plus 1 0, and so here we don't need to worry about that cell. Let's just put columns minus 1, right? And now we've done the first, we've done one, right? We've done the first, let's number them, we've done 1, 3. So here we've done the first one for all of them, for every cell that fits that criteria of 1. Now let's do 2, right? So 2 says for every row, the last column, the cell in the last column should be moved to the row after that and be in the, sorry, here I meant a new grid. Remember, we didn't want to override grid. And so here, well, what we want is we want every cell in every row, every last cell in every row needs to move to the next row's first position, right? So that means we need to iterate over I, right? So for every row, what do we want? We want the grid at this, we want it to move to the grid at I plus 1 0. And remember, we are putting in new grid, so we do like this. And then we want grid at rows minus 1, columns minus 1, which is this one. So moves to this here. So this means that this is, since we are not overriding the grid values, we are going to say new grid, right? Because this is just one iteration, we don't need a for loop. There is just one thing here, is I plus 1, if I keep this row, then the last row, which is rows minus 1, it will get to some index not valid, right? So we will need to do rows minus 1. Also because anyway, that one is already for row n minus rows minus 1, that would be rows minus 1 0 here, right? So the last row first position, which is already handled, right? And so this is, so now we did, so here we did 2, number 2, and here we did number 3. And so now all we need to do is, before the next shift starts, we want the next shift to use a grid, right? To use the values of a grid. But we wanted to use the one that was shifted, so that means we need to do grid equal to new grid, right? Because if we don't do that, what will happen is we'll just override the new grid and we will lose what we just shifted. But we want to shift it once, and then say for example k equal to 3. What we want to do is we want to first shift it once, and then use this result, and then get a grid from that, right? Get a grid from that, and then take that grid and shift it another time. The new grid, right? And so that's why we assign it here again, so that that one would get used. The shifted one will get used, not the original grid, right? And then after that, we could just return grid when we did it k times, right? So about the time complexity, this is O of k, right? This for loop. And this for loop here is O of rows. And this for loop is O of columns. And this for loop here is O of rows, right? And so overall, we kind of have the time complexity here is pretty much O of k multiplied by rows multiplied by columns. We could of course say plus O of rows plus multiplied by columns plus O of rows, but since this side here is bigger, we can just limit it to this, right? In terms of space complexity, well, you could see here we are reinitializing a new grid, which is of size rows by columns. We are initializing it k times, right? So it's still too big, right? It's kind of too big, but just because of the bounds here in the constraint, it kind of works out. Yeah, so that's it for this solution. Let's run it and see if it passes. Yeah, this is actually columns, and this is rows, and this is columns. Okay, cool. So this is the passes the test cases. Next, we'll look at a slightly different solution that is also clever to come up with. So yeah, let's see that solution. Okay, so let's see how we can solve it differently. So let's first take an example. So the first example that we had was this one, where it's a grid that has 1, 2, 3, 4, 5, 6, 7, 8, 9. And the result of shifting that grid is just 9, 1, 2, 3, 4, 5, 6, 7, 8. So one insight we can think of here is that, okay, let's just turn this into one array. Just concatenate the rows and turn this into an array. So that would mean here we'll get 1, 2, 3, 4, 5, 6, 7, 8, 9. And turn this into an array, we will get 9, 1, 2, 3, 4, 5, 6, 7, 8. So this is basically the result of one shift, right? And so what's the difference we can notice here? So we had this entire array of values. You can see this portion and this portion. What do they represent? So this is just if we name this, let's say, I don't know, values, then this would be values, all values except last one, right? And here it's last one value, right? And so what does this one represent? Let's just keep doing this and switch it a second time just to see what happened. If we switch it a second time, you would see that second shift would be that it would be a matrix like this, where you have let's say maybe 8, 9, 1, 2, 3, 4, 5, 6, 7. So you could see again, same thing happens, is that here we have all values except last two, and here we have all values. We have actually the last two values. And this, if you keep trying it on examples, you could see it generalizes pretty well. Actually, we could just say all values, whatever the number of shifts we need to do, you will realize it's just the k. The same thing applies for any k values. And so we could literally just say for the last k values, and here the last k values. So the first portion would be the last k values, and the second portion would be all values except the last k. And same thing here. And so what this tells us in Python, the way to get the exact, so the final result would be just convert to a matrix of rows, and then once we get this, we can just convert it to a matrix of n rows and m columns, and that's easy to do, right? Because that's just saying, if you have a row like this and you wanted to convert it to a matrix of maybe 2 rows, let's say, and 4 columns, well, what you would do is just take the first 4 and then take the second 4. If you have 3 rows and 4 columns, you take the first 4, put them in a row, the second 4, put them in the second row, the third 4, put them in the last row, right? And so it's easy to convert from an array to the matrix. It's also easy to convert from the matrix to the array, because in Python you have a method that does exactly that, which is iter tools that chain, and you just pass it star grid, which means what it will do, it just would convert the matrix to an iterator of a single 1D array, right? And then now all that's left to do is, so we know the first step, which is converting from the matrix to the array. The second step for us is this, doing the shifting, which is, this is shift. And then the third step is to convert to a matrix of n rows. So this is our first step, which is, let's write it in a clear way. So our first step is convert matrix to a 1D array, right? And our second step is, well, shift k times on 1D array, right? So how do we do that? What we said is just the last k values plus all values except last. And in Python, if we say like maybe this is equal to values, then we could just say, okay, it's just values. The last k values, we can obtain them by doing just slicing using minus k, saying this is the last k values first, and then plus we want all the values except the last k ones. And to get that, we can just say all values except, with minus it kind of says except the last k values here, okay? And so now we have the array, 1D array shifted, and then we can convert this into an iterable using just iter here. And that means in our third step is convert the 1D array to a matrix. So convert it back to a matrix, because that's what the result asks us. Let's just call these grid iterator, right? So it's just, or maybe just call it array iterator, because it's just the 1D array written as an iterator, so array iterator. And so to get the matrix, well, we know we want we want it for n rows and m columns, right? And so we could just say for let me just write it in black. So we want something for each column, right? So our columns here, and we want the entire thing for in range of rows. And so we just keep getting the next, right? And so to do that, we can just do next, which is a method in Python, iter tool here, which will basically just takes the first value like this and put it in the first row, takes the second value, put it in this in the second column of the first row, takes one and put it there, takes two, put it here, and then says, okay, we are done with the first column, we are done with the first row, go to the next row, with next, get the next element, which is 3, with next, get the next element, which is 4, with next, get the next element, 5, and you get the idea. It will keep giving us values until we are done with the entire array. And with this 4 in range of columns, we will fill all the 4 columns and then go to the next row. And so now we know what we need to do. We just need to convert from the matrix to a single 1D array, do the shifting using the last k values plus all values except the last k, and then convert back from the matrix to a 1D array. And that's pretty much it. Yeah, so let's solve this problem and make sure it passes test cases. Okay, so now let's type in the solution that we just saw in the overview. So we need to just here put in variables the number of rows and the number of columns. And then just one quick step we can do is, instead of shifting, so for example, let's say the array length is 4, right? It's 4 by, let's say it's 4 by 4, right? Which is 16. If we had maybe k is equal to 32, that means we'll shift it one way and then be back again, which doesn't make sense, which just is a waste of time. So we can just take the modulo, right? Just to make sure we do only the necessary number of shifts, right? And so, because otherwise we'll just keep circling back twice and get the same result, right? And so here we'll do our first step, right? Which we said is convert to 1D array. Which we said we can do that using itertools chain method, right? Let me just show you quickly on command line what that looks like. So itertools, let's say I define this grid, right? So I could just say itertools chain, which you just give it an iterable and returns you a chain of all the values. So here, if I convert this to a list, you can see I just have the entire grid, just one row after the other. 1, 2, 3, 4, 5, 6, 7, 8. So that's what I want for converting to a 1D matrix. And so this is our list of values. And then the second step is to shift using the formula that we said. Shift k times, which we said it's just gives us an array of where we can just say it's values, the last k values, which is minus k, plus the all except the last k values, right? And then after that we will need to just convert it to an iterable so that it's easier to do something. So let's just first put this as values. So that's what we did here. We need a list, right? We need to convert it to a list so that we can do this indexing here. And let's say my k is 2, right? So what would be values plus values? So that would be shifting by 2. So you can see the last 2 values here. And now why do I need to convert it to an iter? Because if I put it in an iter like this, maybe let's call this array iter. If I call next on array iter like this, I'll get the value 8, and then if I do it again, I'll get the value 9. If I do it again, I get the value 1. So you can see here, now I will have filled the first row, which is 8, 9, 1, 2. Do it again. I start the second row, which is 3, and then 4, the second value of the second row, and you get the idea. I just need to keep calling next until I'm done. And so to return my grid, I'll just call next on array iter and keep calling that until I have filled the first row, right, with all the columns needed. And then after that, I'll go to the next row. And that will give me the matrix that the result matrix that I'm looking for. And so this is the last step, which is convert back to a matrix. Okay, so that passes test cases. Yeah, so that's it, I think, for this problem. Please like and subscribe, and thanks for watching. Bye.